welcome to our next type of trigonometric equation. So this time we are looking at solving them when we are adding or subtracting a number to theta inside of the function. So we're going to do these in exactly the same way, pretty much exactly the same way as we did the ones where we were multiplying the theta. So we're going to be changing the interval, but this time instead of multiplying it, we either add or subtract to each part of it. So let's crack on. This example, we want to solve sine of theta plus 60 equals 1/2 for theta between 0 and 360 degrees. So the first thing we're going to do here is change the interval. We've got theta plus 60. So we're going to add 60 to all three parts of the interval of the inequality. So our interval is going to be 60 is less than or equal to theta plus 60, which is less than or equal to 420. So if we sketch the sine graph between 0 and 360, we get something that looks like that. Now, we can get our first solution for theta plus 60 by inversing sine of 1/2. So, if we do the inverse sine of 1/2, we get 30 degrees. So we know theta plus 60 is equal to 30 degrees. Now, sine has a period of 360. So this first solution is back here. Now the interval for theta plus 60 goes from 60 to 420. So we can actually add on 360 to 30 to get 390. Now the reason we've done that is that 30 actually isn't in our interval for theta plus 60. So we are not interested in that value there for theta plus 60. Now what we can do from this, if theta plus 60 is 390, we can take away 60 and get theta equals 330. So that is our first value for theta. Now the other solution that the graph would give us is this guy, which would be 180 minus 30, which would be 150. So that gives us theta plus 60 equals 150. Now, if we added 360 to that, we would be outside of our interval. So we're not going to do that. So all we now need to do is subtract 60 and we get theta is equal to 90. So there in green are our two values of theta. Good times. Okay, example 2, we got 2 cos of theta minus 45 is equal to 1 for values of theta between minus 180 and positive 180. So the first thing we need to do is rearrange the equation a bit, divide through by the 2, and we get cos of theta minus 45 is equal to 1/2. Second thing we need to do is change the interval. So we've got theta minus 45, so we subtract 45 from each bit of the inequality. So minus 180 minus 45 is minus 225, which is less than or equal to theta minus 45, which is less than or equal to 135. So, if we now sketch cos of theta, let's just do it between 0 and 180. We can do that because cos of theta is symmetrical through the y-axis. So, it's going to look something like that. Well, that's 180. And that is 90. Now, what we're solving here is, where is that? Equal to 1/2. So, if we inverse cos of 1/2, we get 60 degrees. So, this value here is 60 degrees. Now that is in our interval, so that is a good one. That is telling us theta minus 45 is equal to 60 degrees. Now, we're not interested in any solutions to the right of 180. That is out of our interval for theta. So, all that we have to do is now think, right, we've probably got to go left then, which we do. So, by the symmetry of the graph, if one of our solutions is positive 60, another one is going to be minus 60. So, the other value for theta minus 45 is minus 60. So if you're not sure where that's coming from, if we carried on this graph like that, the solution here would be symmetrical to the solution on the right of the y-axis. So it would be minus 60. So our two values then for theta minus 45 are positive 60 and negative 60. So if we then add 45 to both sides, or to both solutions, we're going to get, well, 60 add 45 is 105, and then minus 60 add 45 is minus 15. So there are our solutions to this guy. Okay, last example then. So we want to solve 2 tan of theta minus 30 plus 0.8 is equal to 0 for values of theta between 0 and 360 to the nearest degree. So, first of all, rearrange the equation. So if we take away the 0.8, we've got 2 tan theta minus 30 is minus 0.8, and then divide by 2, tan theta minus 30 is equal to minus 0.4. So, now we need to change the interval. So in our function we have theta minus 30, so we're going to subtract 30 from everything in the interval. So we're going to get minus 30, it's less than or equal to theta minus 30 is less than or equal to 330. So as it's tan, I'm not even going to bother drawing the graph. Remember, with tan, to get from solution to solution, you either add or subtract 180. So, using our calculator then, we can get or the inverse tan of minus 0.4 is equal to the nearest degree minus 22. So that is in our interval for theta minus 30. So that is one of our solutions. Well, almost. It's one of our solutions for theta minus 30. So theta minus 30 is minus 22. Now to get the next one, because we're dealing with tan, we just add 180. So that's going to give us 158. Now if we add 180 again, we're outside of our interval. So we don't need to do that. So now to get our solutions for theta, we simply add 30 to each of these. So minus 22 add 30 is 8. And 158 add 30 is 188. So there are our two solutions for theta. Okay guys, that's it for this one. Hope it's helped. Next up, we're looking at solving trig equations using trig identities, which is when it gets fun. So, hope to see you there. Take care.